Alright, last subtopic of chapter 1, which is on charge in a uniform electric field. So in this subtopic, you have to be able to analyze the motion of a charge qualitatively and quantitatively in a uniform electric field for each of the following case. So we have stationary charge, charge moving perpendicularly to the field, charge moving parallel to the field, and lastly, charge in dynamic equilibrium. And lastly, you should be able to use this equation for uniform electric field. Okay, so let's look first at the stationary charge. So let's consider a stationary particle of charge Q and mass M placed in a uniform electric field. Okay, so this charge will experience an electric force being exerted on it itself, which is given, what am I saying? Okay, so basically the electric force exerted on the charge that is placed in the uniform electric field can be calculated using this equation here. Okay, so this is an equation that you can use. Because of the weight of the charge, I think I forgot to add a picture. I don't know if I don't add it because I don't want to. Yeah, I'll add it later. So this is an equation that you can use now to calculate the electric force being exerted on the charge. And then because of the weight of the charge is negligible, the only force exerted on the charge would be Fe, which is the electric force. This net force causes the charge to accelerate. Okay, so basically the picture is, this is the plate. Then if it's a positive charge, it will be attracted to the negative plate here. This is positive lah. Okay, so this is the acceleration. And then the electric force is here, negative, it's going to be up lah, sebab they attracted to the positive plates. And it will also pointing upwards. It will move upwards. Okay, so the direction of this acceleration and force can either be parallel ataupun anti-parallel to the field, and direction of acceleration will have the same direction as the electric force lah. Okay, basically the weight is only negligible if it's very small lah, macam proton macam tu. Okay, so from Newton's second law, we know that force is equal to ma, so we also know force is equal to QE. So rearrange your acceleration, we'll then get an equation something like this. Okay, all right, next, charge moving perpendicularly to the field. So the direction of the electric force will cause it to move in a parabolic path lah. And if the charge is released perpendicularly to the field, we are going to solve it in two-dimensional punya steps lah. Okay, so it's going to be this equation here. So it's going to have y and then x component is not really, do we look at it? I guess we do, but then perpendicular to the field, so they would have an x and y component. Sorry, I got a little bit confused just now. Okay, so we know that the acceleration in the x component is always 0, so we know that the final velocity will be equal to the initial velocity. So it's going to be constant. And final velocity in the y component is going to be equal to at, and then sx, this one ni kamu sudah belajar dari last semester lah, okay, which is the kinematics of linear motion. All right, next, charge moving parallel to the field. If the particle has a positive charge, the acceleration is in the direction of the electric field. Okay, kalau dia negative, dia akan berada in the direction opposite to the electric field lah. Okay, because electric field always go from positive plates to negative plates. Okay, so positive charge will be attracted to the negative plates, hence they have the same direction as the electric field. However, for a negative charge, it will be attracted to the positive plates, hence it will be opposite of this electric field lah. Okay, and these are the equations that you will be using in order to solve any questions regarding charge moving parallel to the field lah. Okay, and lastly, charge in dynamic equilibrium, it will continue moving in a straight line because the total force is equal to 0. So instead of it being attracted to any of the plates, regardless of the charge, it will continue moving in a straight line. Okay, why? Because basically the weight of this charge and the electric force is balanced. So when they are equal, the charge is gonna move in a straight line. When there's a value bigger, which is not gonna happen in dynamic equilibrium, barulah dia ada motion yang moving towards either of the plates depending on the charge lah. Okay, all right. So next we have to understand about the relationship between uniform electric field and potential difference. Okay, so it can be calculated using this equation here. The negative sign just indicates the value of electric potential will always decrease in the direction of electric field. Okay, so kalau electric field tu pointing here, maksudnya electric potential is decreasing as it goes further away. Macam tu lah. As it follows the arrow, something like that. Okay. Okay, so this is just a graph. This is just an example of electric field with its parallel plates, and then so D is the distance between these parallel plates lah. Okay. All right, so now let's look at example number 6. We have two parallel plates connected to 100 volt, positive 100 volt and negative 100 volt respectively. So that is just telling us the delta V. I want to use this, which is equal to 100 volt. So if an electric field of 4000 volt per meter is produced between the plates, so what is the separation distance between the plates? So this is just very straightforward. That is just delta V over D. So D is equal to delta V over E, and this is gonna give you 25 millimeter. Okay, so that is just applying the formula into the question lah. So I guess the trick here is just knowing what is the value of delta V. But delta V is just basically the value of volt being supplied lah, which is 100 volt. Okay, so the change in potential difference is 100 volt. Last example for this whole chapter, example number 7. A uniform electric field exists in the space between two identical parallel charged metal plates. So the plates are 1 centimeter apart. So given is the plates are 1 centimeter apart, I would call it as D. An electron is released from rest, so that is equal to 0 at the negatively charged plate. It arrives at the positively charged plate 2 nanoseconds later. So what does that tell us is this is so it's gonna be from so this is positive. Okay, so it's gonna be like this. You don't have to draw this in exams. This is just how I would explain it to you. Okay, so an electron is released at this negative plate here. So it's gonna be negative charge. And then it arrive 2 nanoseconds later at this point here. So from point A to point B lah, macam tu. Okay. So now this is charge moving parallel to the field. Okay, anti-parallel parallel, basically just parallel to the field lah, tapi it is in the opposite direction of the electric field. So if you look at the notes back, you can actually know what equation should we use, which is basically some of the equation that we've used last semester lah, okay? But first, we need to calculate the electric field strength. So the electric field strength is equal to F equal to QE. So from here, E is equal to F over Q. So we already have the value of Q, which is just the charge of the electron, which is 1.6 times 10 negative 19 coulomb. Got it? Okay, so from here, we just have to find the value of F. And we know that we can apply Newton's second law of motion here, which is equal to MA. So force is equal to MA. So we can do that here, MA over Q. We, however, do not have the value of A. So how do we find the value of A? If we look at what's available, we know we have VU plus AT, V square U square plus 2AS, and we have S UT plus half AT square. Okay, so if we were to use these two equations here, we have a problem finding the final velocity. So we can't actually use this, so we are gonna try and use this equation here. But what is the value of S? The value of S is basically this here, okay? So this is our value of S, which is the separation between the metal plates, okay? The charged metal plates. So we can then use that equation. So I'll let that equal to D, S is equal to D. U here is equal to 0 because it starts from rest, okay? So it is released from rest. So when U is equal to 0, we are left with half AT square. So rearrange for A, we'll then get 2D over T square. So we substitute that into this equation here, which is going to be M 2D over T square over T over Q. Okay, so from here, if I do it bagus-bagus sikit, you have QT square. Macam tu lah. So the electric field strength will be equal to 28468.75 Newton per coulomb. Okay, so that is the electric field strength. Okay, next, that is, it's not hard, it's just a bit more complicated because you have to use kind of more than one equation. But it's not complicated if you think about it carefully. I mean, if you list down, if you remember these equations, then it shouldn't really be a problem lah. Okay, so next we have to determine the speed of the electron when it arrives at the positively charged plate. So it arrives 2 nanoseconds later, and if we look at this, we can actually again reuse one of these equations ataupun use new equations, but basically I'm just going to use this one because it's much more easier, and the information is already there lah. So this is U plus AT. So V is what we are looking for. This is 0 plus the acceleration, which is 2D over T square. T, cancel this, so we are left with 2D over T. So just substitute all the numbers and you will get 10 times 10 to the power of 6 meter per second as the final velocity ataupun the velocity as it reach the positively charged plate lah. Okay, all right, so that is on example number 7, and that is the whole subtopic number 4. So what you need to remember here is, First, you have to basically know that you can use this equation as well, not to be confused with our previous subtopic. We have kq over r square. And then what else do we have for electric field? I think there's something else. I just don't quite remember. Oh, delta V over D pun, one of the equation. So basically, if you have parallel plates, charged metal plates, you can use this. Just don't forget that you have these three equations just to find electric field strength lah. Sama juga macam force. Force pun boleh guna yang ini lah. Okay. And then what else? So just trying to remember the equation here. This one as well lah. Stationary charge. Basically, just try to remember the equation that you can use for different types of motion for these four motions. Okay. And then lastly, yeah, that's pretty much it actually. Okay, so basically that is all for subtopic number 4, and this is our whole chapter 1 for this semester.